Hey, everybody. I thought that it might be helpful to make a little web interactive to help you with some supply and demand things where, we have a sales tax that's imposed on a producer, and you just want to play around and see um, what the equilibrium price is, producer and consumer surplus, deadweight loss, government revenue. So I made this little interactive, and it doesn't really fully cover every possible situation, but it's a useful way to kind of play around, see things. So let's go to let's see if I can get into my Safari and share my screen, and we'll see if we can get this thing done. Let's see, where is Safari? Here we go. So here's this web interactive. By the way, it's actually it's rapmasterhap.shinyapps.io, and then it's / supply and demand interactive. That's just one of those goofy things. But let's do some examples. So the way this thing is set up, I have these little sliders over here. So you specify a demand curve. So here, what happens if the price is 0? What's the demand? That's where the demand curve hits the x-axis, maximum of 100. So Q equals 100 is kind of the maximum you can do on this thing. And then what's the decline in demand associated with a $1 price increase? Here it's set to 1, but you can slide it over. If you want to try, different slopes of the demand curve. And then how much of the good will the supplier provide if the price is 0? If you want to have a positive y-intercept, you can sort of move this thing around. But I'll just leave it at 0 for the moment. Oops. Yeah, there's an annoying thing manipulating these sliders. Then how much does the supply increase if you increase the market price by $1? Here it's set to 2. So it's a linear supply curve. And this one is actually quantity supplied is equal to 2 times P. And then what happens if we impose a sales tax on the producer? Here it's set to 0. Okay, so if I stop sharing and I go to a Word document, I can show you, what all of the all these quantities will be. Here it figures out an equilibrium price 33 1/3, equilibrium quantity 66.2 Pardon my dog in the background. No tax revenue because there's no tax. Actually figures out the price elasticity of demand and the price elasticity of supply at equilibrium. Tells you the consumer surplus. You'll see this is actually a little wrong. It's calculated numerically, and it actually adds it up. It divides this thing up into 100 little pieces and adds things up. It's a little bit off, but very close, you'll see. And the producer surplus, again, it's a little off because it's a numerical calculation. And then it calculates the consumer and producer share of the sales tax. So like here's a little graph that it makes. So here's the supply curve, which is pretty responsive to price. Here's the demand curve. Consumer surplus is going to be the area of this triangle. Producer surplus is going to be the area of this triangle. And it figures out what this point is. And it's actually 66 2/3 and 33 1/3 over here. But I should have had to write the little the amounts over here. I didn't do that. I'm a B+ R programmer. So let's actually just look at the math of this for a second. It's pretty straightforward. Let's go to Word where I just worked it out. Here we go. So there's no tax. So the demand curve is 100 minus P. The supply curve is 2P. There's no tax. So the price is just where 100 minus P equals 2P, or 100 equals 3P. You work that out. P equals 33 1/3. Q then is just going to be 100 minus P, which is 66 2/3. I'll leave you to work this out. It's pretty easy to do. Now the consumer surplus is going to be 1/2 times 100 minus 33 1/3. That's 1/2 base times the height. So this is the y-intercept of that demand curve minus the equilibrium price. multiplied by the quantity. So you get 2,222.22. Producer surplus is 1/2 base times the height, where it now becomes the equilibrium price, 33 1/3, multiplied by the equilibrium quantity, take half of that. And there's no government revenue. So you see it's a little off. If you look at these numbers, if I just go back to the interactive for a second, you'll see the interactive is a little off. Let's see if I can find so far. Here we go. See, it should have been 2, 2, 2, 2, 2, all these twos across. Not quite. It's a little off. And this should be just ones all across. It's a little off, but it's pretty close. And it gives you the equilibrium price and quantity, exactly where they should be. Okay. Now, what happens if I take this thing and I put a little tax on? I'm going to make a $10 tax. Slide this thing over to 10. Okay. And now what it does is it draws the new supply curve that's just been shifted up by the value of the tax. So there's going to be a government revenue, which is this guy here. There's going to be a new consumer surplus, which would be a little smaller, which is this guy here. There's going to be a new producer surplus, which is this triangle in here. It's going to be a little smaller. And there's going to be a deadweight loss, which is right there. And it calculates all those things out for you. You see deadweight loss, 33 1/3. Consumer surplus, it says 1798.5. And producer surplus, 899.25. Now note here, the consumer's paying 2/3 of the sales tax. Why is the consumer paying 2/3 of the sales tax? Because the supply curve is a lot flatter. That's why that's happening. So let's just stop sharing and just look at the math for that for a second. Share the screen again. Let's go now to Word, see if I can find it. So now we've got this tax here. So the demand curve is 100 minus P. The supply curve is 2P, but then we add the tax in. So the producer doesn't get P. The producer gets P minus 10. So we have this equation, 100 minus P is equal to 2 times the quantity P minus 10. You work all this out and you get P equals $40, Q equals 60. Okay. So, if you can stop the YouTube video here if you want and just look at the math. It's pretty straightforward. Government revenue is just Q equals 60 times $10 per unit sold, or 600. Deadweight loss is how much the quantity has come down, and 1/2 base times the height, where the height of that triangle is how much the quantity has come down, and the base is just the amount of the tax. So we're going to get $33 Bender. You're making a lot of noise. Consumer surplus is going to be 1/2 100 minus 40. That's the y-intercept minus the equilibrium price times the quantity. That triangle, you get 800. Producer surplus is 1/2 of how much the equilibrium price is above the minimum that the producer demands to produce anything. So it's 40 minus 10 there, times the equilibrium quantity is 60, and you get 900. Okay. Now, what did we get in the interactive again? If I stop sharing and I just go back to the interactive. I got equilibrium price of 40, just the way it should be. Equilibrium quantity of 60, tax revenue 600. Calculates the elasticities. Deadweight loss, 33 1/3, just where it's supposed to be. Consumer surplus, a little off. It should be 1800. Producer surplus should be 900. It's 899.25, pretty close. And it shows you here. Again, I should have, if I was better at R, I would have this thing showing better graphics. But here's the little deadweight loss triangle. Here's the government revenue. We've got our producer surplus in here, and we've got our consumer surplus in here. So you can just play with this and say, how would that change? Like, for example, suppose I took the tax and I made it 20. Okay. Now notice the deadweight loss has really exploded. It's now 133. See, that triangle is a lot bigger now. It was 33 before. Now it's about 4 times that. Remember, the deadweight loss goes up like the value of T squared. Okay? And it's going to calculate the new consumer surplus and the new producer surplus that's taken a hit. And notice, by the way, the equilibrium price is $46.66. Okay. Or if you say, what happens if I make the supply curve really elastic? So let's suppose that I say now the supply increase associated with the $1 price increase is not 2, let's make it 10. Okay. Now what's happening? First of all, the consumer's bearing almost the entire increase in the equilibrium price. Turns out the consumer is actually bearing 90% of that price increase. It actually calculates for you, what's going on there. It's because the producer is just a lot more, it's a lot more price elastic than the consumer. They're and you can see price elasticity of supply at equilibrium 2.2, price elasticity of demand at the equilibrium 10 times, 1/10 of it. Tax revenue 818, and that's just equilibrium quantity is 81, and the tax is 10, and so on. So you can sort of play with this. If I move the tax up to 20 again, my deadweight loss goes to 181. And the equilibrium price is now 27. Again, the consumer's bearing almost all of that. So you can just kind of take this and play with it. By the way, we could also say, what happens if I subsidize that good? Suppose I pull -10. Okay? So now it's pulling down the supply curve. I think I may have pulled it down a little bit too far. Let's see. Oops, you know what? I think that this made it, notice the equilibrium price is 0. You might say that's a little weird, but of course, if the producer is being subsidized, they can provide it free. And of course, if they provide it free, how many is the consumer going to buy? See, it's right here. Consumer's going to buy 100 units. Interestingly enough, by the way, there's a deadweight loss triangle. It's this thing, because it costs society, some money to produce that stuff. Let me make this just so it's a little bit less weird. I'll make it -5. Okay? But by the way, there's nothing that was wrong about having that good be free if it was subsidized. But let's just make it -5. So now what happens? So now the equilibrium price is 4.5. Okay? And the equilibrium quantity is 95. Tax revenue negative. Now you might say, but there's something wrong with the program. No, it's because it's paying out a subsidy. That's why it's doing that. And there's a deadweight loss. There's a consumer surplus, which is a monster. And there's a producer surplus because we're subsidizing the producer. And the consumer gets almost all the benefit there of this thing. Okay? So this is like the childcare problem. So you can kind of take this thing and play with it. And it's kind of interesting. And it's just a little thing that I made that you can kind of play with. And it's, again, numerically, it's going to be a little bit off because it's calculating everything. So you're within like 0.5% of the correct answer numerically when you're doing this out. Yep. I'm going to stop recording now.